Okay, our next podcast moves into another topic of the study of the chemical context of life. And for the next few topics, we're going to be looking at the importance of molecules and um, atoms at the that and elements that are important for the study in biology. So this isn't a chemistry course, but there are some important aspects of chemistry at certain levels of biology. So that's where we're going to start. We can say that uh, basically biology is a multidisciplinary science, and so we include a lot of different areas in biology, and one of those areas is the molecular area. Um, so, Molecular biology is kind of the study of matter as it relates to living things. So, matter consists basically of the chemical elements, and those can combine to form compounds and matter. So matter is made up of elements, and elements are things that can't be broken down any further um, into any other substance. And a compound is a substance that consists of two or more elements. So here's an example here. This is an example of a compound that's made up of two substances. The compound is normal table salt, sodium chloride, and it is made up of two substances, sodium and chlorine. And when these are combined, these elements make sodium chloride. Now, for us in biology, there are um, certain elements that are important for our study in biology, and there are other elements that are not as important. So in biology, there are about 25 of these naturally occurring elements, and that are important for living things, or they either make up living things. Um, there are about four of these that really make up the living bodies themselves, the structures of living things, plants, animals, fungi, and bacteria and things. So of those 92 elements, there are four of these: carbon, hydrogen, oxygen, and nitrogen, that make up the majority of living matter. And so that other 4% are a few other elements like calcium, phosphorus, potassium, and sulfur. All right, so these are the essential things um, for life. So here's our example there. The elements, there's symbols for these elements, and these are arranged onto a periodic table that we'll look at in a minute. But so here's the symbol. Here's an atomic number, and so we're going to look at what that atomic number means here when we look at the structure of the atoms. Before looking at the structure of the atoms, we mentioned in the outline here a few important figures that had a contribution to our understanding of chemistry and these atoms that we have. One is Michael Faraday. We mentioned he was the first one to actually break down a substance or break down a compound into its basic substances. And so he was the first to kind of recognize this uh, lowest level of physical matter. And then John Dalton, he is had a contribution in coming up with what we now know as the atomic theory, that elements are made of atoms, and then these atoms are the smallest basic level that a physical thing can be broken down into, and then we have the development of the periodic table from that. All right, so these atoms, these smallest things that a substance can be broken down into, are made up of subatomic particles. All right, so our subatomic particles are our protons, neutrons, and electrons. All right, so each of these has a certain charge. Neutrons have no charge, protons have a positive, and electrons have a negative charge. And all physical matter is made up of these subatomic particles, just in different ratios. So whether we're talking about a dirt or a piece of grass, or the structures in your body, or a rock, all physical things in the universe are made up of atoms, which are made up of these subatomic particles. Now, the arrangement of these is that the protons and neutrons are found in the central portion of the atom. We refer to that as the nucleus, and the electrons are found in the outer portion of the atom. This outer portion is referred to as a cloud or shell, but these subatomic particles, electrons, move about in this outer cloud or shell. And the protons and neutrons, they stay stationary in the central portion of the atom. Okay, and these electrons are going to play an important role when we start talking about bonding and how these bond together by either sharing or giving of these electrons. Okay, so in this example, we have 2 protons, 2 neutrons, and 2 electrons in this atom here. Okay, so we have some numbers that we can refer to when talking about these atoms, and those are the atomic mass number and the atomic number. So the atomic mass number would be the combination of the protons and neutrons. So here in this example of this atom, we have an atomic mass number of 4. And the atomic number, the element's atomic number, is the number of protons in the nucleus. So protons would be 2. So it has a atomic number of 2 and a mass number of 4. Okay, we'll also mention isotopes here. Isotopes are when we have an atom that has the same number of protons, but then we have different number of neutrons, and those are referred to as isotopes. So these are 2 atoms of that have different number of neutrons. Okay, here's an example of part of the periodic table where we can see the configuration of the atom here, where the protons and neutrons are here and the electrons are in the outer shell. This top level is going to represent where the first shell is either it's not past filled up. So in order to fill up the first shell, it's required to take 2 electrons to fill up the first shell. All right, so the electrons in the first shell requires 2. Hydrogen has 1. We see the 1 dot here. Helium has 2. So it is now full. Once it fills up 2 electrons in that shell, it has to move to another shell, which would be lithium. So we move to the second row because a second shell is required. Lithium has 3 electrons. And so we have 2 to fill up the first, and then 3. Beryllium has 4, so we have 2 to fill up the first, and then we have 2 more. Boron has 5, and hence we can see that 5 is the atomic number, and that's listed here. Carbon has 6, so we have 2 in the first shell, and then 4 in the next shell. so forth. All right, and then to fill up the second shell, we require 8 electrons. So neon has 2 to fill up the first, and then 6 more, and it fills up 8 in the next shell. So if it had one more, it would require another shell. Like sodium has one more, it has 11, and it goes to the third shell, and that's the third row on our periodic table. So this is looking at how we distribute the atoms on the periodic table, but also showing you the arrangement of the electrons in their orbital. All right, so the valence electrons are what we refer to as this outer shell of electrons. So in hydrogen, it is the first shell. In this second row, we're talking about the valence just being this outer shell, because those are the ones that are going to be important when we start talking about bonding. So that valence, or the outer shell, is important. All right, so let's get to bonding. Bonding is when we form two different atoms. They can join together by either sharing or giving and taking of these electrons in the valence shell. Okay, there's two different types of bond. The first one we're going to look at is covalent bond. This is the sharing of a pair of these valence electrons. So the sharing of these is called a covalent bond. And so here we can see an example of these when two hydrogens are bonded together. So this is showing it in the cloud form. Hydrogen has one electron in its valence shell, and so when we bring two of these together, they each have one, and they can share one because they require two to fill up that valence shell. And when they share one here, it's like they each have two. So that is filling their outer shell. So when two hydrogen atoms come together, they can complete their outer shell because they're sharing each other's one electron to make for two. And so we can represent that in a formula right here, H2, because we have two hydrogen atoms that bond together. Okay, so that's a simple example of a covalent bond where these atoms each share one electron. Okay, so we call it a single bond when they just share one pair of electrons, such as hydrogen. So here's our example of the hydrogen here. So we have the molecular formula H2. This shows the electron distribution right here. So each dot is representing an electron. So each hydrogen is bringing one, and they're sharing that one with each other to make two. So each atom then is considered to have two. And to be full, that's what the atom tends to want to try to do, is fill that outer shell with the number of electrons required. This is different ways of representing that bond as well. The Lewis dot structure is putting a dot here for each individual electron, and then the dash is representing a bond. So just different ways of representing that. Okay, so oxygen can bond. We can have two oxygen atoms. Oxygen has two in its first, and then it has 6 in its outer shell. So it still needs 2 more in that outer shell to fill the required 8 is what it needs. So when two oxygens share those 2 pairs, then that is representing a double bond. And so we can see that with 2 dashes, or you can see that with the 4 electrons, 2 pairs that are shared there. And then these other examples are when we have two different atoms that share to fill up. H2O is an example. 2 hydrogens bond and share their electrons with an oxygen to fill that up. Okay, we're going to stop here with covalent bonds. We'll pick up in the next podcast talking about ionic bonds and some further discussion about chemistry.